We're going to go ahead and build on everything that we learned in 1.2 about transformations and apply it a little bit further. Specifically, we're going to go really in depth about all the different types of transformations as opposed to the few that we learned in 1.2, and we're going to apply them specifically to linear and absolute value functions. Now, there are three main types of transformations. There's translations, reflections, and stretches and shrinks. And each of these three have a vertical component and a horizontal component. So what I want you to do right now is pause this video and copy this information down so that way we can do it together. Now, like I said, each of these transformations has a vertical component and a horizontal component. And then also we need to pay attention to what it does to the equation. So if I'm talking translations, you can have a vertical translation and you can have a horizontal translation. So if I have a vertical translation, what that means is I have some function f of x, and I am going to move that function up or down. So anytime I have a vertical change, and you're going to notice this in translations, reflections, and stretches and shrinks. Whenever I'm talking about a vertical change, the operation is going to get done to the output of my function. So for a vertical translation, I've already got my f of x function, which means it is the output, because as you guys remember, f of x and y are the same thing. So if I have my f of x, and then what I need to do is either add something to it or subtract something from it. And we call that something a k value. It can be really any value that you've got. It's just we use k as a placeholder for the vertical shifts. If I have a plus k, that means my graph is going to move up. And if I have a minus k, that means my graph is going to move down. Again, that gets done to the output of my functional values. If I have horizontal translation, what happens there is that the operation gets done to the input. It's the x value that's going to have the operation done to it as opposed to the y value. So I have y equals f, and then notice I've got this x value. And instead of closing that parenthesis and then doing plus or minus something, we're actually going to do it on the inside of the parenthesis. So I've got plus or minus some h value, and then I close my parenthesis. So notice that operation is happening inside of the function because it's happening to the input as opposed to outside the function happening to the output. Now, it is very easy to fall into the trap and think plus h means right, minus h means left, but it's actually not like that. If I have x plus h, that's actually going to mean left. And when I have x minus h, that actually means right. And it seems like it would be counterintuitive, but it's not. It just so happens that the formula that's used has a minus on the inside. And so whenever you substitute values in, what ends up happening is a negative and a negative multiply and it becomes a positive. So it looks like a plus sign on the inside, and vice versa. When I already have a minus sign and I substitute in a positive, it looks like a minus even though that value is actually a positive. So again, whenever I have a vertical change, it's going to occur in relation to the output. When I have a horizontal change, it's going to occur in relation to the input. When we're talking about reflections, there's also a vertical component and a horizontal component. So my vertical component is going to be a reflection over the x-axis. It's going to be a reflection over the x-axis. So if I have an absolute value function and I want to reflect it over the x-axis, notice how that's a vertical change. And the way that that's represented, again, I'm going to manipulate my outputs. So I'm going to say y equals negative f of x. So notice how that negative, I'm multiplying to all of the outputs. And if I want a reflection over the y-axis, notice that's horizontal because if I have my absolute value function and I reflect it, that's a horizontal change. And that's going to affect my inputs. So I have f, and I'm going to make my x values negative. Now, horizontal stretches and shrinks and vertical stretches and shrinks are closely related in the sense that they have similar setups. However, again, it's going to be relation to the outputs and relation to the input. So if I'm talking about a vertical stretch or shrink, I am going to take my output values and multiply it by some factor, and I call that factor A. So again, it's going to go on the outside of my function. And whenever I have a horizontal stretch or shrink, that's going to be in relation to my inputs. So notice that A value is going to be multiplied into my inputs. Now, how do I know when it's a stretch and how do I know when it's a shrink? You have to be careful because it is actually the opposite from vertical and horizontal are opposites of one another. So if I have an A value, the absolute value of A is greater than 1. Now, the reason I say absolute value of A is because notice above right here, I could have a negative A value, but we already know that the negative deals with the reflection. We are not dealing with stretches and shrinks when we're talking negative. So don't just think greater than 1, less than 1, okay? So if my absolute value of A is greater than 1, then this is going to be a vertical stretch. Vertical stretch. You can't just say stretch. You can't just say shrink, okay? Because there's two kinds. If the absolute value of my A is between 0 and 1. Notice I did not say less than 1 because less than 1 includes negatives. And we already said that negatives are reflections. So if the absolute value of A is between 0 and 1, that means it's going to be a vertical shrink. And again, we're talking about that A being multiplied to the outputs. Now, if I have an A being multiplied to the inputs, and I have an A value, the absolute value of A is greater than 1. This is actually going to be a horizontal shrink this time. And if the absolute value of my A is between 0 and 1, then that means it's going to be a horizontal stretch. So it's the opposite. So you're looking at the value that's being multiplied. Is it being multiplied by all of the outputs or is it just being multiplied by the inputs? And then depending on that, you're going to decide, is it a stretch or is it a shrink? And obviously if it's horizontal or vertical. Now you should have already copied this example down. If you haven't, pause the video and copy it down right now. It says, let f of x equal absolute value of x minus 3 minus 5. Write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. Also write a function h whose graph is a vertical stretch of the graph of f by a factor of 2. So I'm being asked to do two things. I'm writing two different equations. A g equation, which is horizontal shrink, and an h equation, which is vertical stretch. So let's do the g equation first. It's telling me I'm going to take my f function and I am going to change it to where now I've done a horizontal shrink by a factor of 1/3. Now some of you are already thinking, hold on. Right there at the top of your notes, you just told me in order for something to be a horizontal shrink, it has to be, the A value has to be greater than 1. How in the world is 1/3 greater than 1? You're right, you got me. It's not. If I have a horizontal shrink by a factor of 1/3, I am going to compensate for that by multiplying my inputs by 3. So Make sure you understand that part right there. In order to compensate for a horizontal shrink by a factor of 1/3, I'm going to multiply my inputs by 3. So I have my g of x function, and my g of x function, like I said, we're going to multiply my inputs of f of x by 3. So I'm going to take my f function, and I'm going to multiply the input of x by 3. So notice I'm multiplying that input of x by 3. Just like over here. I'm taking that a value and I'm multiplying it by my x. But that's just the stand-in. Now I actually have to go replace it with the actual f of x function. So I'm going to say g of x equals, my f function was absolute value of x minus 3 minus 5. But now I have to multiply my x value by 3, just like that. Now there's nothing to distribute, there's nothing to do here, so that actually means my final answer is g of x equals absolute value of 3x minus 3 minus 5. One more time. Whenever I'm being asked to do a horizontal shrink by a factor of some fraction, you are going to multiply it by the reciprocal of that fraction. So I was being asked to do a horizontal shrink by a factor of 1/3. So I multiplied the inputs by 3, the reciprocal of 1/3. Now let's go do my h function, which is asking me to do a vertical stretch by a factor of 2. Now vertical stretches and shrinks are way more straightforward. Since I don't have to think about reciprocal or anything like that. Greater than 1, absolute value being greater than 1 is a stretch. Absolute value being between 0 and 1 is a shrink. So I start out with my h of x function. And I need to do a vertical stretch by a factor of 2. So I'm going to multiply all of my outputs, just like up here. Just like that a value being multiplied by my whole function. I'm going to say 2 times my f of x function. Now I can go replace that f of x with the actual f of x function. Now some of you are going to be able to skip this step, and that's totally fine. Just be aware that you don't make any small mistakes when you're skipping any steps like that. So I'm going to say 2 times, and I'm going to multiply my entire f of x function, which is absolute value of x minus 3 minus 5. Now I need to distribute, and you cannot distribute that 2 inside of the absolute value bars. It does not work like that, and we're going to learn about that some more next week. So I have h of x equals 2 times the absolute value of x minus 3 is just 2 absolute value of x minus 3. But then I can do 2 times negative 5, which is negative 10. And that is the vertically stretched function. We're going to just do one more example where we do a combo move. We do a bunch of different transformations at once. So go ahead and copy this example down. Let me move myself out of the way. And then you can pause the video to copy this down. It says write a function k whose graph is a horizontal stretch of the function f of x equals absolute value of x by a factor of 3, followed by a reflection in the y-axis, then moved up 6. And you know what? I actually changed my mind. Since we already have done something with a 3 and a 1/3, let's change by a factor of, let's do 2. We'll keep it simple. Okay? So I'm having 3 things done to my function. I have a horizontal stretch, I have a reflection, and I have moving up 6 in that order. So I do need to follow these rules in that order. K is my final function, but until I get to K, I need to keep placeholders for these first 2 transformations. So let me start with f of x. I know that f of x is the absolute value of x. So I'm going to first do horizontal stretch factor of 2. Okay, now if you recall from the previous page or from the front of your notes, horizontal stretch means my A value must lie between, or my absolute value, my A value, must lie between 0 and 1. 2 clearly does not lie between 0 and 1. So then you think back to the other example we did about horizontal stretch and shrink. And remember, I have to use the reciprocal. So I'm not going to multiply my inputs by 2. I'm going to multiply my inputs by 1/2, the reciprocal of 2. Now I can't go ahead and jump to my k function because my k function is my last function. So to do my just horizontal stretch function, I'm going to use g as a placeholder. I'm going to say g of x equals, and you can use any letter you want. I just went f to g, okay? I already have my absolute value of x, but now I'm going to multiply the input by 1/2. So right now I've just compensated for my horizontal stretch. Now I have to do a reflection. I have to do a reflection in the y-axis. So reflections in the y-axis, again, are going to be dealing with the input. I want to make my inputs negative. So I already did g, let me go to h. h of x equals, I've already got absolute value of 1/2 x, but now I need to make my x values negative. So I'm going to say absolute value of 1/2, that was already there, negative x. And then I've got my absolute value finished off. Now, you do need to make sure that you simplify. So I'm going to simplify this and turn it into h of x equals absolute value of negative 1/2 x. Notice I just multiplied that negative and that 1/2. And now finally, so I've done 2 of my transformations. I can finally move on to my last one, which is moving up 6. So then you're going to look on the front of your notes and you're going to say, okay, how do I show moving up or down values? And that is by adding or subtracting to the outputs. So I'm going to take the whole function, and I'm finally to my last function, so I can go ahead and say k of x equals absolute value of negative 1/2 x, and I am going to add 6 to the outside of my function. And that is all 3 transformations at once. If you have any questions, be sure to ask them during class.